Hello everyone, welcome to KRX 9.8. Myself Abhishek Shakti here. Today is the fourth lecture in differentiation. In first three lectures, we have did the questions based on the basic derivatives, like using the chain rule, and like the whatever those basic derivatives are like d by dx of sine x, that is cos x, d by dx of sine cos x, that is minus sine x, d by dx of tan x, that is sec square x, d by dx of cot x, that is minus cosec square x, d by dx of sec x, that is sec x into tan x, and d by dx of cosec x, that is minus cosec x into cot x. Using the chain rule, we have did all the questions which I have explained in the first three lectures. Now, every time we are not going to use the chain rule, like you assuming t is equal to something like that, v is equal to something like that, we are not going to use that one, because sometimes you will find we are getting u dot v function, u by v functions. So every time we are not applying that assuming t is equal to xq. So we will use some shortcut method to differentiate the given functions. So let us, without wasting your time, let us come here and we will try to solve the previous questions for first three lectures using the shortcut method. Okay, so have a pen and paper and try to complete the lecture in one shot. Let us come here. If I will take the first question, y is equal to sine of xq is there. So how we will do this type of questions? We know that d by dx of sine x is nothing but cos x. And I have explained in the first three lectures. Let's say we have after sine we have a x is there, so we are differentiating the given function with dx. If after sine we have a t, we will differentiate with dt. Correct now? Now see, if I have to differentiate this given function, so what we will do? Sir, we will assume like you told, like in the previous three lectures, whatever the change is there from the original function, the change is from in place of x we have x cube. In place of x we have a x cube. So using the chain rule, what we used to do in the first three lectures, sir, assume the change as some variables, like we are taking t is equal to x cube, and this function will become y is equal to sine t. Correct na? Correct, sir. And if I have to differentiate this function, what I will do? Sir, since after sine it is x, we are differentiating with dx. So after sine it is t, we will differentiate with dt. So d by dx of sine x is cos x. So d by I will write d by dt of sine t will be what? Sir, cos t. And what is your t is there? So t is nothing but x cube. So if I will differentiate with respect to dx, that is 3x square. So the final answer will be d by dx of is equal to dy by dt into dt by dx. Keep the values here. dy by dt is nothing but cos t. Sir, cos t into dt by dx, that is 3x square. Keep the value of t. So cos of t is nothing but x cube into 3x square, and this is your final answer. Correct na? All these things we have seen in the first three lectures. Now we will try to write this answer in a single line. See here, I am writing. I am directly writing dy by dx. See, dy by dx. See, after sine, whatever written, sir, xq is there. So whatever written, that is the theta na. After sine, anything is written, that is the theta of the sine. Correct na? Correct, sir. So sine x differentiation with respect to dx is cos x. Now what you have to keep in mind, sir, after sine anything is written. It's here written x cube, if it is written t cube, p cube, anything is written. Sir, if it is written ax square plus bx plus c, something written after sine, you keep in your mind that this is your x only. What I told? After sine, whatever written, you have to consider as a x only. So sine x differentiation will be what? Sir, cos x. Okay. You have to write it here only. In mind you are keeping as x, but when you have to write the actual one. Okay. Is it x? No, sir. Then differentiate this also. So x cube differentiation is with respect to dx is 3x square. And say this is your final answer. So in this lecture, I'm going to take all the questions of the first 3 lectures and we will solve like this only. Okay? Okay, sir. Let's go for the other question. Go for the other questions. Pause it and then just try to understand. In this lecture, I will not tell you to write anything. Just try to understand what I am doing here. So it will be very helpful for the next lectures. Let's say if I am taken let's go with the other question. Sir, y is equal to cos cube x. I told you whenever you see this type of functions or the way they have written cos cube x, first write like this one. Sir, cos x whole cube can I write? Yeah, you can write. Now what you are doing in the first 3 lectures? Sir, whatever inside the bracket, if bracket to the power something is there, it will be differentiated in the form of x to the power n form. And x to the power n form differentiation is n into x to the power n minus 1. Correct? Now, the change is for solving this one, if you are doing with a chain rule, what do you do? Sir, whatever inside the bracket, you consider as a t. Like t is equal to cos x, t is equal to cos x. If I will consider t is equal to cos x, so my function will become y is equal to t to the power 3. So if I will differentiate this function, this is x to the power n form. Arey bhaiya, y is equal to t cube. If y is equal to x cube is there, we will differentiate with dx. If y is equal to t to the power 3, y is a function of t, so I will differentiate with respect to dt. Correct na? Okay, sir. So I will differentiate dy by dt is nothing but 3t square. I think you know all these things. X to the power n form. T to the power 3, n is 3. So n into x to the power n minus 1. 3 minus 1 is nothing but 2. So 3t square. And what is your t? So t is this one. T is equal to cos x. T is equal to cos x. I told you after cos whatever written, that is the theta. So you have to differentiate the given function with respect to the given theta. So if I have to differentiate, I will differentiate with this function with respect to dx. So dt by dx is equal to, sir, cos x differentiation with respect to dx is minus sin x. So minus sin x. And I have to write dy by dx. So dy by dx is nothing but dy by dt. Dy by dt, that is 3t square. 3 and t is what? So t you have assumed as cos. So cos square x into minus sin x. So this is the final answer you have. If I have to write this one, I will write in one line only. See this one. This we have did already. I have explained all these things in the first 3 lectures. Correct na? I have explained you all these things. Now try to understand, see how I am writing all this, how I am differentiating this given function in a single line. Whenever it is written like this one, you have to first write like this. Now our function is y is equal to cos x ka whole cube. Okay. Now whatever inside the bracket, you just keep it as a x. Whatever inside the bracket, keep it as x to the power 3. So if it is x to the power 3, just in mind only you keep as a x. Sir, x to the power n form is there. If you will differentiate this one, dy by dx, what is? Sir, n, whatever inside the bracket, write it. N x to the power n minus 1. Is it x? No, sir, it is cos x. I'm going to differentiate that cos x. Cos x differentiation with respect to dx is how much? Sir, minus sin x. Okay, minus sin x. See, this one and this one is the same. The above one and the down one is same. Okay. Understand? Everyone, tell me everyone, understand? Yes, sir. Go for the next one. Go for the next question. Y is equal to tan root x. All the questions we will try to understand. Now I am writing directly to just match the answer. First 2 questions I have taken that what we have actually did in the first 3 lectures and now what we are going to do in this lecture. So y is equal to tan of root x. Directly I am writing dy by dx for this one. After tan anything is written, consider in your mind as x only. After tan anything is written, because we know d by dx of tan x, we know d by dx of tan x is sec square x. This we know already. So after tan anything is written, because we after tan x is there, we are differentiating with dx, and the differentiation of this function is sec square x with respect to dx. Tan x differentiation with respect to dx is sec square x. So tan root x differentiation they are asking with respect to dx. So what I will do, after tan anything is written, you consider as a x only. So what will be the differentiation? Sir, sec square x. I told you have to keep it as only. And is it x? No sir, root x. Root x differentiation with dx. Many times I told you to remember this root x differentiation with respect to dx. 1 by 2 root x. Root x differentiation with respect to dx is 1 by 2 root x. Root x will be differentiated. Root x is written na. So root x I can write x to the power 1 by 2. The x to the power n form. If you solve, you will get 1 by 2 root x. And this is your answer. Sec root x, sec square root x by 2 root x. Sir, this root x and this root x will cancel out. Never cancel out. This root x is the part of this one. This is the theta of sec. You can't cancel this root x and root x. Many times I have seen the students doing this one. That's why I am showing all these things. You don't do all these mistakes. I have seen the students doing all these mistakes. Okay? Okay, sir. So what is the final answer? So the final answer is sec square root x by 2 root x. Understand? Everyone tell me, understand? Okay, sir. Go with other question. Other question. Go with the other question. Sir, if it is written like, sir, question is like this one, ki y is equal to 2x plus 3 to the power 5. What about this one, sir? It's a bracket. Whenever you see the bracket, the differentiation will be in the form of, how we will differentiate this one? Sir, it will be differentiated in the form of x to the power n form, always. Whenever you see the bracket, the differentiation, to differentiate the given function, you have to use x to the power n form. So here whatever, if I am writing dy by dx, all these questions I have did by the chain rule. See, here also I am doing the chain rule only. But I am not writing exactly in my mind. I am doing all these things. So whatever inside the bracket, consider as a x only, x to the power n form. Whatever inside the bracket, consider as a x only, x to the power n form. What will be the answer? Sir, n into x, that is 2x plus 3, n minus 1, that is 4. Is it x? No sir, it is 2x plus 3. I can differentiate that one. Sir, if I will differentiate 2 x differentiation with dx, tell me, x differentiation with dx, sir, 1 plus 3, sir, 3 is a constant. Constant differentiation is 0. So 2 into 1 is 2 into 5. So 10 into 2x plus 3 to the power 4, and this is your answer. Got it? Someone saying, sir, do this one. Y is equal to root under ax square plus bx plus c. Sir, what will be the dy by dx for this one? Nothing is there. Whenever this function is written, your first duty is to, if I have to find dy by dx, your first duty is to, for what? Sir, first write in the bracket form. Whenever root is there or cube root is there, first your duty is to write in the bracket form. What you will do? Sir, this can be written as y is equal to ax square plus bx plus c to the power 1 by 2. Now if I have to differentiate, after that I will differentiate this function. So dy by dx is equal to what? X to, whenever you see the bracket, it will be open, it will be differentiated in the form of x to the power n form. So x to the power n form, if you are differentiating, what will be there? Tell me. N, whatever inside the bracket, you have to consider as a x only in your mind. Whatever inside the bracket, you have to consider x only in your mind. But while writing, you have to write actual thing. While writing, you have to write the actual one what is written here. So n x, like n minus 1, 1 by 2 minus 1, 1 by 2 minus 1 into, is it x? No sir, it is ax square plus bx plus c. I can differentiate that one. If I am differentiating, a is taken outside because a is the constant, and constant multiplied with the variable, you have to take it outside. I have explained all these things in the first 3 lectures. So a is taken outside, x square differentiation. Sir, it is x to the power n form. X to the power n form means n into x, n minus 1, 2 minus 1 is 1, plus b is taken outside, x differentiation with respect to dx is 1, and c is the constant, so differentiation is 0. So what will become? So 1 by 2 into ax square plus bx plus c. 1 by 2 minus 1, LCM. You know all these things. So this will be minus 1 by 2 into 2ax plus b. And you know, if the power is, if you see on this one, ax square plus bx plus c, the power is minus 1 by 2. So if I will take it downward in the denominator, the power will become positive. So I can write like this one, 1 by 2 into ax square plus bx plus c to the power 1 by 2, and the numerator part we have 2ax plus b. This is in the numerator. Now this 1 by 2 can be written in this form. 1 by 2, this is nothing but the root. So to make it 2ax plus b, 2 root under ax square plus bx plus c. See, don't cancel this 2. 2 is multiplied with this one. I can't cancel this one, 2 to 2. 2ax, it's not exactly only 2 in the numerator part. So don't do all these mistakes. Okay? This is your final answer if I am doing directly. Have a pause and just think that what I am doing here exactly. Okay? Understand? Okay. Go with the other question. Go with the other question. Let's see. Other question. I'm taking one question. Y is equal to root under 1 minus tan x. Y is equal to root over 1 minus tan x divided by 1 plus tan x. Everyone tried at this question. Not by the chain rule. This method only. Directly what I am doing here. Just pause it and then try. Pause it. Sir, what I have to find here? I'm only one question. dy by dx. Find dy by dx. Find dy by dx. Quickly. Okay? You tried it? Just see. See here. Sir, whenever the bracket is written, first I will write, whenever the root is written, I will write in the bracket form. Okay, very good. Y is equal to 1 minus tan x divided by 1 plus tan x to the power 1 by 2. This is. And if I have to find the dy by dx, directly I am doing. I will write directly answer. See. Sir, bracket to the power something is written. Means it will be differentiated in the form of x to the power n form. Whenever bracket to the power n is written, it will be differentiated in the form of x to the power n form. So x to the power n form, if I will differentiate, what will be there, sir? N into x. X is the whole. 1 minus tan x divided by 1 plus tan x. N minus 1. 1 by 2 minus 1. Okay. Is it x? No sir, it is 1 minus tan x divided by 1 plus tan x. I can differentiate that function. So if I will differentiate this function, this is one function is 1 minus tan x. Other function is 1 plus tan x. And it is written in u by v form. Are you getting this one? Have you seen this is one function 1 minus tan x divided by 1 plus tan x. So if I will differentiate this one, this is nothing but the quotient rule, u by v. Remember what I have taught you for u by b, d by dx of u by b form. Sir, left the v, differentiate u, minus left the u, differentiate v, divided by v square. Correct na? Correct, sir. Now come here. So left the v is 1 plus tan x, u is 1 minus tan x. So left the v means 1 plus tan x into dy dx of 1 minus tan x. Okay, minus, I'm just remove this one so that I will not find. You understand na? Written na? Just left the v, differentiate u, minus left the u, that is 1 minus tan x, into dy dx of v, that is 1 plus tan x, divided by v square. V square is nothing but 1 plus tan x ka whole square. So what we have? Let's do this one. So this is 1 by 2 into 1 minus tan x divided by 1 plus tan x to the power 1 by 2 minus 1 by 2 into, come to this part, this overall part. Okay, now see here, 1 plus tan x into d by dx of, sir, you taught me whenever there is a plus and minus, differentiation will be distributed on plus and minus. So if I will differentiate 1 minus tan x, first I will differentiate 1, d by dx of 1 is 0, minus d by dx of tan x is, sir, tan x differentiation with respect to dx is sec square x. Correct na? Yes sir, sec square x minus sec square x. Okay, minus, you write like this one, 1 minus tan x into d by dx of this function, 1 is again 0 and plus tan x, that is sec square x, divided by this whole divided by 1 plus tan x ka whole square. You understand what I am doing here? Okay, now simplification is there. You know all these things. So this is written 1 by 2 and the power is minus 1 by 2 is there. Power is minus 1 by 2. Minus 1 by 2 means if I will take it downward, it is written as 1 by 2 it is written as, this will come, whole thing will come in the denominator. Denominator means if I will take it, this whole thing will come in the denominator. I can write like 1 minus tan x divided by 1 plus tan x to the power 1 by 2 into, now solve this part. Sir, it is 1 plus tan x into, sir, first multiply, minus sec square x is there na? Okay, minus sec square x is there. So what I will do for this one, minus sec square x, can I just multiply all those things? I can multiply all these things. Yes, I can multiply. Let me see, whatever I am writing in the down part is coming. Okay, no problem is there. Because of the change in angle is there, little bit looking tilted, but you will find those things. I'm just explaining you the how to do the direct methods with the direct method. 1 into minus tan x square x, so minus sec square x, plus tan x into minus sec square x minus tan x into sec square x, minus 1 sec square x into 1 भैया sec square is the, if you open this one, this is -1 minus minus plus. So -1, if I'm first I will multiply sec square x into 1, sec square x with minus sign. So minus sec square x minus minus plus into tan x into sec square x. So tan x into sec square x. I think other parts you will do. The way this is the last one I am doing here. 1 plus tan x ka whole square. Simplification you can do. You can see something here. So this is here plus. So plus tan x into sec square x minus tan x into sec square x will get cancelled. Minus sec square x minus sec square x, it will come minus 2 sec square x. Okay. And you can see here, this part will also go. 1 plus tan x will go above. So you can simplify this one. If you simplify this one, okay. Understand? So what will come? See here. So 1 by 2. Can I write like this one? Root is there, no? So above it will, this part will go above and this part will come down. So I can write 1 minus tan x. 1 plus tan x. Like this one. To the power 1 by 2. This part will go above. Here it will come into minus 2 sec square x divided by 1 plus tan x ka whole square. So this 2 to this 2 will get cancelled. So sec square x is also written as 1 plus tan square x, but I can't find anything. So this is the final answer you have. Just note it down if you find it useful for you. Just note it down whatever I have written there. So you understand how I'm actually doing the things. That is the main point I have to for this lecture. This lecture is only to explain you that how I will how I'm going to do the differentiation directly from the next classes. Okay, I will not assume every time t is equal to x cube. See, whenever the new function will come, I will do that one to explain you. But the bigger functions will come where u dot v is there, where u by v is there. There I am not going to take t is equal to something. I have to do the direct method. Understand? Okay, sir. Let's do with the other question. See, simplification is there that you can check in my previous, I think the second lecture will be there. Second lecture is there. First or second lecture is there. You can see how I simplified this one. Or you also try, no? You have to try how you simplify this one. My motive is to make you understand how we are actually going to do direct differentiation of this type of functions. Okay? Okay. Let's go for some few questions and we will end today's lectures. Let's try y is equal to cos square x square. Question. Y is equal to cos square x square. Find dy by dx quickly. All these questions I told you we have to directly you do. Directly you try this question. Direct method. Direct method. Sir, first I will write like this one. Tell me. Sir, cos of x square ka whole square. Because here theta is x square. When a square is on this one means I will write like this one. Correct. Sir, you are interested in finding dy by dx. Yeah, dy by dx. Sir, this is bracket to the power n form. Bracket to the power n form means it will be differentiated in the form of x to the power n. And x to the power n means, sir, n. Okay, whatever inside the bracket, n minus 1, that is 1. Is it x? No, sir. I'm going to differentiate that one. The cos theta, cos x differentiation is cos x. It is not x square, but you have to consider in mind only x. Cos x differentiation is minus sin x. While writing, you have to write the actual one. X square differentiation. Sir, x square differentiation is 2x. That's your answer. So we have minus 2 into sine of x square into cos of x square into 2x. Acha, tell me, you remember one formula, sine 2x, that is 2 sine x into cos x. 2 sine theta into cos theta. Sine, after sine it is written x is nothing but a theta. Sine theta cos theta 2. So can I write this one as a minus sine 2x square 2 theta into 2x. So this is your final answer for this question. I think everyone have understand how actually I'm doing. Who have attended my previous lecture, they are getting. I think those people are getting what I'm doing here. This is a direct method to solve all these questions. Okay, should we go for other question? Let's do other question. Sine of, try other question. Y is equal to sine of cos x square. Y is equal to sine of cos x square. Find dy by dx. Everyone try this question. Every individual try this question. Direct method only. Okay? Pause it and then try. Okay na? Let's come here. I am solving this question. Sir, dy by dx you are interested to find? Yes, I am interested in finding dy by dx. Tell me. Sir, after sine anything is written, I will keep in my mind as a x only. That I am explaining you from the last 30 minutes. I am explaining all these things only na. This only na. After sine, whatever written in mind only you consider as a x. So sine x differentiation is cos x. I told you while writing you have to write the actual one. But is it x? No sir, it is cos x square. हम can differentiate this function. So this is written cos of x square. So whatever after cos considered in mind as a x only. So cos x differentiation is minus sin x. Is it x? No sir. So then again 2x. That's the final answer. So what we have? We have minus sine of x square into cos of cos x square into 2x. Now see, we can't apply sine 2 theta formula. Sine theta, cos theta, theta is different. So we can't apply that formula which we have used in the previous question. Understand? Understand? Okay. Let's say I will take one more question to explain. This question I think will be very helpful for you. Y is equal to 1 by root over a square minus x square, and I have to find the dy by dx. First, everyone try from your side. I'll take water a little. Everyone try from your side. Direct method. Okay. Direct method. Tried? Let's see. Sir, first write in the proper format. Proper format means, sir, first this root can I write as a square minus x square to the power 1 by 2. Yes. And if this will go above, I can write as a square minus x square to the power minus 1 by 2. Okay, very good. Well, this is my y is there. My y is now a square minus x square to the power minus 1 by 2. Now I have to differentiate this function. So dy by dx. Tell me everyone. Dy by dx, what will be there? Sir, it's a bracket form, x bracket to the power n form. And whenever there is a bracket to the power n form is there, it will be differentiated. It will be differentiated with the help of which form? Sir, x to the power n form. It will be open with the help of x to the power n form. X to the power n form means n, that is minus 1 by 2 into x, whatever written you consider as x. N minus 1, minus 1 by 2 minus 1 into, is it x? No, then differentiate that also. Means dy by dx of a square minus x square. Now solve this part. Sir, minus 1 by 2 into a square minus x square to the power. Sir, it will be, if I take LCM, it will come minus 3 by 2 into d by dx of a square. A is constant. Whenever it is plus and minus is there, differentiation will be distributed on plus and minus. Okay, so a square differentiation will be 0 minus 2x. So this is my final answer. You can see here, this minus and this 0 minus 2x, minus 2x, so minus into minus plus, and 2 will get cancel. So we have x into a square minus x square to the power minus 3 by 2, or else I can write x by a square minus x square to the power 3 by 2. If it will come in the denominator, the power will become positive. And this is the final answer. Okay. Directly I am doing. So all the questions whatever we have discussed in the previous lectures, you will try those questions by this method only. Try those questions by this method. I think this much will be very helpful to understand that how actually we are going to do the questions directly. Okay, so whatever the questions we have did for the last 3 lectures, you practice all those questions directly. From the next lectures, I will explain you also with the chain rule also and direct method also for the exponential and the logarithmic function, which we are going to discuss in the next lecture. So what's your duty is there? Your duty, I told you from the first lecture only. Go with the revision of the formula. That is very, very important. Formulas like 1 minus cos 2 theta, 1 plus cos 2 theta. 1 minus cos 2 theta is, sir, 2 sin square theta. 1 plus cos 2 theta is, sir, 2 cos square theta. Sin 2 theta is 2 sin theta into cos theta. Sir, what is the formula of tan 2 theta? 2 tan theta divided by 1 plus tan square theta. Sir, is there any formula of sin 2 theta in the form of tan theta? Tell me. Go and please search those formula which I have written. I told you, make your write all the formula in a in one page and add. That time also I have told you, leave some pages so that whenever the formulas will come, you will add those things. Okay? Okay? So be happy, be healthy. Thank you.